Absolutely. Thank you so much, Michael. So today we're here to talk about how to make the data scientists in your organizations happy. And in this case, the context is enterprises. So like large enterprises, really old legacy infrastructure, and that journey towards doing open source Python and understanding what that looks like. I am Hussain Sultan Tim Horan. We are ex-Capital One. I'm a PyData associated with that, also Dask as well. That picture, by the way, I was just like one day taking off my headphones, and somebody took it, and it just came out perfect. You guys cannot see it like in a high res here, I guess. But the truth is, it was like the 31st shot. All right, so a few things have happened over the years. On the right-hand side, there's an explosion of data. 90% of today's data has been created over the last 2 years. That's huge. Cloud computing is making its way into highly regulated industries. Also a big development. And then there's common software development patterns that are being established for sustainable analytics. These three things lead to open source adoption, predictive analytics advancement that we are all witnessing today with AI, with deep learning, although deep learning might be like 100 years old. And then infrastructure automation as well, which is huge in order to have velocity around how you take a new insight from the ground up to the market. All these things come together in what we call modern analytics, and we'll talk about that more. In 2014, Gartner said, hey, okay, so big data is and modern analytics here are basically these efforts that have failed in the past. And Gartner in like 2014 said, hey, 60% of these projects are toast. However, 2017 rolls around, and it's really like close to 85%. And the reasons behind it is that, like, the analogy that I'd make here is if you go grocery shopping and you don't know how to cook, you may not be able to do anything or provide value from your trip to Whole Foods or wherever you go. That is something that has been a common thing that I've seen in especially large enterprises, where we'll buy large Hadoop clusters and set them up, fill the lake, but that lake may not be very useful because there's no end user in mind, or if there is, the use case may not be appropriately created. For this reason, these like immense failure that we have seen and like we observe, we are blaming today the unhappy data scientist.
Great. So just to dive into that and explaining why we think unhappy data scientists are to blame, we wanted to start with a game. Hopefully you're familiar with this game. So it's not exactly this question from Kindergarten Cop, but it's, who are your data scientists in enterprise and what do they do? So these are the various roles within a data-driven enterprise that's trying to bring insights to market using data. And then generally, what do we see them doing in these enterprises? So for example, business insight generation versus model building, model deployment. And just kind of to walk through an example, if data engineers looking at source systems, moving it into more like analytical databases, those analytical databases are used by data scientists to build models. Those models are used by business analysts along with other intent and intuition to drive in-market strategies. And then those strategies are translated by developers and brought into production through DevOps. Just one example of kind of how these groups work together. And so there's some observation we've seen when we put this together. So one, data scientists play this really critical bridge role between what are traditionally like IT roles and then the business. I think this is similar. I think Peter said it better than I did in terms they almost are that third dimension between the IT triangle and the business intent on top. And it's a critical role for being successful in these endeavors. Additionally, deployment in enterprise is requires everybody's engagement. It's one of the few things that everybody needs to be aligned on in order to be successful, and that'll show up in why that's a challenging effort. So then the question is, how do you make them happy? Given that context, how do you make data scientists happy? So I think that's what you're here for. And we think it's, based on our extensive research, it's mostly slides, alcohol, and snacks, lots of snacks. While these things are all really great, it's unfortunately, it's harder than that. So I think a good thing to start with is, why are data scientists even there? Like, what gets them up in the morning? What makes them excited? And I think simply, if I had to say, it's they want to drive change in organizations using the data. And so in order to do that, in order to be happy, in order to be successful, it begins with the first word, data, right? They need access to data. They need some way of understanding what the heck the data is or where did it come from. They need the tools to then analyze that data, the platforms to analyze that data. Some governance, but reasonable governance on open source, and then finally, transparent paths to bring those insights and models into market and drive the value they want to generate. What we've seen, though, is that last part is the part that's really the kind of the linchpin on being able to actually do these things in enterprise. Thinking that path from insight to impact. We've seen a lot of places they'll develop a proof of concept or something, but it's not able to ultimately get into market. And so, I think the question is, why is that so hard? And so this is a common structure we've seen. It's not always this way, but this is what we've seen at a couple places where an enterprise, to be an enterprise, they have to have some BAU processes already. They have business analysts, data scientists implementing things into a production infrastructure that it's existing. They have a monitoring and analytics stack, and then they're using that, doing that cycle over and over again, oftentimes for maybe decades. And in the modernization process, often then some sort of parallel lab or center of excellence is stood up. A on-prem Hadoop or cloud-based database is created. A new ATL process is created to fill that lake or populate data. And then scaled data science environment is set up. Those are connected. Data scientists do what they do, drive new insights, model strategy, and then finally, ideally implement that into the old implementation process. There's a couple challenges we've seen, or common challenges we've seen with this structure. So one, I think Hussain mentioned it a little earlier on, but the new ETL process is oftentimes the key performance indicators for that process are filling the lake, or how much data do I have there, what percentage of my data is there, versus thinking through, well, how is this data set up so it's the most useful to the end user, which obviously could create challenges depending on how it's put there. Additionally, the new implementation process is oftentimes the new insights, new models, new strategies, it doesn't fit into the old implementation process. Whether it's because it's old infrastructure and you're trying to put in these new models or things that didn't exist when the implementation process was first built, this creates a lot of challenges. So either you're going to have to figure out how to jump big hurdles, or you run into a brick wall and literally you can't implement it at all. And you can imagine, as a data scientist who maybe spent months trying to ground a new insight or build a new model, it's a pretty frustrating situation. So we believe there's got to be a better way, and we'll walk through that now.
Yep. So we recommend that you have to essentially start off with a use case, which drives some ROI, or there's a direct understanding from the business that this will deliver or just solve for a need. And based on that one use case, you then start your journey around modernizing analytics infrastructure, building your use case and your data products, and then sustaining it over time and iterating towards this grand, beautiful vision that a center of excellence may have already, to put together. On the identify part, we believe the use cases need to be actionable. They need to be material. On the actionable piece, the example is, I have an insight. What do I do with it? Can I take some action? Can I change my strategy? Could I market a different segment or unlock a new segment? On the materiality of this thing, we basically understand around how is that being profitable and the dollar value of it. The last part, which I think is the most important, is it has to align with your strategic mission. And in our experience, there's like big data modernization, some kind of transformation agenda is generally already something that the leaderships have bought in. But you need to make sure that what you're doing is aligned with the overall goal of the corporate strategy.
Great. So to walk through an example of a use case, and then we're going to walk through our modernization process of that particular use case. We're going to start with an example from financial services. This is a response propensity model for marketing for a consumer lending company. So basically determining who you should market to get your product, basically, or get your loan or credit card or whatever it may be. So we start with the analytical database. We start with business analysts and data scientists building out. Oftentimes, in this case, it was a linear model for response, predicting probability of response based on historical marketing campaigns. With that and other inputs, a business analyst then builds out a targeting or marketing targeting strategy. Who are they going to send mail to? Who are they not? One of the things that's a challenge in financial services, a little bit of a side, is that you don't want to just mail whoever's the most responsive, because those are people oftentimes who are also the riskiest. So it's a little bit of a matrix and a trade-off of who's responsive but also not super high risk. And then finally, in this case, we actually work with a third-party implementation and data partner. This is like a credit bureau, so TransUnion, Equifax, Experian, if you've heard of those. And we work with them to ultimately then send out the marketing prospects and non-marketing prospects. So this gives kind of like a high level of what we'll be talking about.
By the way, this part is the exact process of like how you get a mail offer from a credit card in your mailbox, and it's like super annoying, but that's how you target and get selection.
So you want them to get better at this, so then you don't have to throw away as much mail, hopefully.
And hopefully less annoying.
Yeah. Cool. So we just want to put it through a litmus test of, is this a good use case? So we're going to walk through the three items that Hussain mentioned. So is it strategically important? So oftentimes these marketing programs are the main drivers of growth for the lending business. And growth is an important part of their business. Acquiring new accounts is an important part of the business. So it feels like it fits in this as strategically important, and it should be an important part of the business that executives tend to care about and want to learn more about and get better at. So actionable. So this one is a little bit more complicated. So we think, like, there's one obvious example here is you have a linear response model. Is there opportunity to use like a machine learning model, a GBM? And so if you could do that, you think that this could be improved. However, we at this time, when we're just initially looking at it, we don't know if we can implement GBM in our third-party partner. So right now, before we can say this is a great use case, or at least until we have to verify, that's got to be one of the first things we do. We have to verify that that's even possible. If it's not possible, then we shouldn't invest time in building out the model because we won't be able to implement it. And finally, material. So material here is really how many people can I book and what are those worth? And if I can do that more effectively with a better response model, that's my material outcome. So it's actually pretty tangible, which is helpful for this use case. And so then the question is, okay, let's say I improve the response lift 10%, is that material enough to justify the investment I need to make in modernizing this? And if it is, then maybe you say, okay, I think I can do that. Let's move forward. A couple places where it might not be material would be if I already market 95% of the population, then an incremental amount is not really all that helpful. Or if the overall population is really small, then it might not be worth investing in this particular group with the response model. So it's important to kind of really understand what are you trying to drive towards at the end. Okay.
Cool. So most of the places that I start off with, they have some type of a legacy system already set up, and it basically starts with like some kind of monolithic database, Oracle DB2. If you're unlucky, it might be mainframe and COBOL, which is cool. And then you have you basically like you may have a SAS server where the statisticians or the data scientists are interacting with these data sources and doing analytics. And the SAS server, you basically have some friction there where you will port that data over or connect to it and save it as a SAS file. And then the third part, which is a critical piece of infrastructure, is the production environment or the actual campaign execution. That part is, in our example, it was like we were required to like basically translate the SaaS model into C code. If it's a linear model with like 20 variables, it's maybe a 30-minute effort to code it up and about 25 weeks to validate it. But like that's sort of how it works out, and then you will be able to essentially market to your prospects the ones who are most likely to respond and the ones that you're most likely to approve, because it's like there's a risk on the other side of it. Now, like typical way, the loop goes like you basically created your main data set. The statistician or the data scientist is going to build a response model, and then it will be ported over, like handed to a software developer who will like take the SAS code and try to write the more like production quality code and like translate that thing into C, and then it's basically going to go back to the developers to like manually check and like test and like validate that it was in fact accurately implemented. And it's usually a very manual process. You use a lot of Excel and like back and forth, and you hope that all things are coordinated and you will be able to execute your campaign in time. On the same side, the business analyst will take that output from the model and try to build the policy on it and understand the segmentations that they want to market, are they profitable or not, and then be able to come to a decision. That itself is an isolated process as well. It basically fits in its own world, and you may not be communicating too much with the data scientists, and they may not really understand exactly what your target is, because the model may not be exactly doing what the business really wants. And like that process again is another sort of loop, and then you go back and you like test that and hopefully get to a place where everything worked. So now your response models are passed, they get implemented, and you are in market. The first pain point that we see is that the legacy infrastructure, especially SaaS, and I'm not like particularly trying to hate on SaaS. I think it's a great product, but it may not allow you to iterate quickly enough or have limitations around the type of techniques that you may want to experiment with. So you are generally in the SaaS world, like the most complicated models that I've seen are linear models, and maybe there's some like decision trees that then get implemented as linear models, but at the end of the day, you're mostly in the linear model world. Nothing wrong with that if it works for you. The second pain point that I talked about a little bit is a very manual process, and everything is a handoff, and everything is an email, and you don't have Slack, right? So, but you'll be able to it's a process that will be always a bespoke, hand-rolled execution of that intent.
Great. So that was our old infrastructure. So now it's a question of how do we invest in the new for this use case. So we started by looking at all the various pieces and then trying to make a decision on where and how to invest. So starting from the edges, you have our source system and then the production C environment. Changing these, obviously, like we don't even own the production environment. It's at that third party. So that doesn't seem like a place where you can actually change it. Source systems are older. However, moving those, there's all these dependencies. The whole company might be using those source systems. And even if we did change them, that alone wouldn't really help us make better decisions. Ultimately, we would still need to build new models. So for those reasons, we left them out of place where we're going to invest time. So the next question is more of that modeling and analytics environment, that SaaS environment. We thought about saying, okay, should we redo that part? But as we dug into it deeper, one of the things we found was SaaS was also being used as kind of the ETL from source systems into more like analytical databases. And so if we were going to get rid of that, we would have to actually recode all the ETL into a different language for an open source environment, which again wouldn't actually help us make a better decision for this particular use case.
Or in this case, you could also like you may find that you have this a particular version of DB2, and you'd have to actually write a connector in Python or R, and that may be an expensive process that you may not want to take up front. You will basically say, hey, I will just use SAS as my information gathering layer, but not an analytics layer.
Yeah, and I think that hits on the next point of being, this is building technical debt. I think it's something, the open source sandbox solution is likely not the end solution for what we would want to actually implement. You eventually probably would want to, if you were trying to move away from SAS into more open source tools, you would eventually want to recreate that ETL. You'd want to make those investments. And in this way, we're actually kind of kicking the can down the road. And while on the surface that might not seem like the right idea, I think it's, as long as you're doing it knowingly and making that decision as an enterprise or as a product team or whatever it may be, it's probably fine as long as you're aware of that. You might need to go back and redo some of that. Finally, now with that sandbox available, data scientists are able to build out more modern response models. So in this case, they built a GBM model using XGBoost. And one of the challenges, though, was now XGBoost isn't, the output of XGBoost isn't C code. So we had to figure out a way to how do we take that GBM and move it into the C production. And that actually was some of the investment we made in this use case. So it was creating basically a thin software that translated like a model dump from an XGBoost into C code that could then be implemented in production. And by doing that, now we've enabled the team to be able to continuously iterate on models and still be able to move them to production.
So the XGBoost bit is a repeatable Python package that you can always use over time, and it's there to stay, but eventually, hopefully, it will go away, right? Yeah. But it's sort of the thin abstraction layer for us.
Yeah, we didn't put it in here, but I mean, there's an option where you actually would more create like an API that the production would ping, which I think they would be capable of, but given where we were at this particular client, it wasn't really an option, and so this was the path of least resistance to get us in market as quickly as possible. Finally, this was a slightly smaller effort, but we built a way before it was kind of a back and forth with the intent from the business analysts, we built a way that kind of mimicked more of the production data and system on the local side, and then be able to test your intent prior to sending it over. It didn't really solve entirely the passing back and forth, but it did make that process less iterative and more likely to be right the first time. Cool. So, as you can see through this, we were very laser focused on how do we drive incremental change or benefit as quickly as possible, really focusing on the key pain points being the lack of tools and then also the iterative process back and forth to implement.
So remember the sort of the architecture that we've laid out, that you have this modernization that is happening in parallel, and we have this enterprise BAU. And so now with this use case, what we have done is that we have sort of taken the best pieces of the legacy that we think are pertinent to our use case, the legacy infrastructure in this case, and sort of marrying that like open source and the best-in-class analytics, and putting it into a place where we could somehow iterate on it. So it's an interim state, but it's a state that allows you to tap into the open source goodness quickly, and then be able to still not have to be super disruptive. And what that looks like is that you have a little bit of Python inside your legacy processes, and you have a way to test in an automated way, and you also get this automated production path. It's not exactly automated, but the until the C code part is automated at that point. And if you are you have this setup, and you can iterate on it, and you could say that, hey, I don't like this SAS ETL one, and I have my HDFS data lake, so let's move the marketing prospects' data onto the lake, figure out the technologies that you want to use to process it, maybe Hive, and then you iterate upon that step. And similarly on the production side, you exactly do the same thing and figure out how to implement the type of analytics that are important to you into a place that could be consumed by the end user. And the model itself, it basically looks like you have a product. So you have built a team or this virtual team inside your organization that is a collection of multiple skill sets from data engineering to DevOps, the handlebar mustache guy there, and you have a backlog, and you can basically say, okay, now my response model, I have a new data that I want to evaluate for my response model, and you test, build, and deploy, and you try to make sure that loop is as fast as possible. This is the loop that will basically drive a lot of the value in terms of speed, and then also in terms of the end sort of material results that we may be after. So if you do this thing long enough and you have enough to support, and you're lucky, you may end up with something really cool where you have a data scientist who are just committing to GitHub, and that GitHub commit triggers a CI/CD pipeline that basically goes and talks to your computational frameworks like Spark, Dask, MapReduce even, and kick out those targeting and the model validation results that can then be collectively reviewed with the business analyst and the data scientist, and then you have a way to deploy it into your production systems in a easy sort of quick iteration way, and a kind of repository here can be used to basically version your production models as a Conda package, and you can now say, hey, the response, the strategy that I implemented last month, that wasn't good enough. I'm going to roll back to the old one, and you could do that without really thinking about it a lot, and you know exactly what to expect from that result. So now the data scientist, the question is, how do you make them happy? And if there's one thing which I think is important here is that a transparent path to creating and impacting your end customers. If you do not have that, your data scientists are basically analyzing a lot of data maybe, but may not be able to ever feel satisfied and fulfilled. There's a Stack Overflow survey that talks about how that data scientists are most likely to change jobs, and it's an important thing. You have to make sure that when you hire or grow your team, they're set up for success, and success comes in many ways here. The first part is that business impact, but the most important part is that you are impacting the customer through your product. The takeaways. So work backwards from a use case. This is very, very, sort of intuitive thing to say and an intuitive thing to understand. It's very hard to do in reality. You are going to get distracted. Who here has heard about fraud use case as this one major Hadoop use case? You may not care about fraud, or you may not get that ROI, or that might not be the quickest path to disrupting and making sure you are modernizing both your people, the processes, and the technology. How do you do that well? And it's really important to have a laser focus on the use case and understand those needs really well up front, and then be able to deliver. And then identify a path to implementation ASAP. It's important. If you cannot do that, you are basically going to have super long, 8-9 month long model building projects that are frustrating and may not actually deliver the value that was the promise to the business team who may have funded this whole analytics modernization work.
Yeah, and building on that a little bit, thinking MacGyver versus Michelangelo, I think there's a saying that perfect is the enemy of good. And while I think that makes sense, I think the only addition you would add is that technical debt is a real thing, and being aware of where you are kicking things down the road and making sure that that's a thoughtful decision. But generally, you want to try to get value as soon as you can, because it kind of snowballs on itself, right? Like as you have successful use cases, more will be funded, and it'll snowball nicely. And then finally, I think organizing around products. We shared in the beginning how so much has changed in the last 10 years, and there's no reason to believe it won't continue to change. And the way to insulate yourself from that change or be ready for that change, especially in enterprise, is to be aligned around a product and iteratively improving and making the right investments on where to improve as that product evolves and as the world changes. Cool. Thank you. I think we're going to do questions.